On number 4, we're doing something very similar to number 1, except for, we're still dealing with x squared, we're still dealing with from 0 to 8, but this time they want us to use 8 rectangles, and this time they want us to use right Riemann sums. Let's first figure out what delta x is. Again, delta x is our width of each rectangle, because they each have to have the same width. This will be 8 minus 0 divided by 8, which is 1. So let's see if I can space this out somewhat good. This will be 1, this will be 2, 3, 4, 5, 6, and 7. That's okay. Again, if you want to graph x squared on the calculator, you can. I've kind of warped it a little bit so that it's easier to draw the rectangles. So with right Riemann sums, it means that the right corner of the rectangle needs to touch the curve. So on this first interval here, on the left Riemann sums, that wasn't really a rectangle because the function crosses at 0. But here, because we're only concerned with the right corner of the rectangle, we actually will get a rectangle here. And then this rectangle is going to touch here. This rectangle is going to be like that. And so on. And just like before, we do want to know the height of each of these rectangles. And we can get that by plugging in the values into the function. So if you plug in 1, then you get 1. If you plug in 2, 2 squared is 4. If you plug in 3, 3 squared is 9. 4 squared is 16, 25, 36, 49, and 64. So then I need to figure out the area of each of these rectangles and add that up. So I'm taking the width times the height. So this will be 1 times 1 plus 1 times 4 plus 1 times 9, and you don't really need to show the 1 times because it's not changing anything. So if you just want to add up the squares, you can. 1 times 36 plus 1 times 49 and 1 times 64. So if you type this into your calculator, then you should get 204. So this is definitely an overestimate of what the actual area is. So on number 1 it was an underestimate because there was a lot of gaps. Here this is an overestimate because all of these rectangles are over top of the curve. So this would definitely be an overestimate of what the actual area is. But again, they're just asking for an estimate.